Introduction to Rational Functions. I'm Anil Kumar and we'll take up the very basic question and try to understand what rational functions are. Let's begin by understanding polynomials and operations on polynomials. When we add, subtract or multiply polynomials, we always get a polynomial. This statement is always true. Now the question is, if we divide a polynomial by a polynomial, we get a polynomial. This statement is always true, sometimes true, or never true. That is the question. So the operation of addition, subtraction, and multiplication on polynomials will always result into a polynomial. But if I divide two polynomials, that is to say, if I have two polynomials, px, p of x and q of x, and that's the operation I perform, will I get a polynomial or not? Or do I get polynomials sometimes, or the answer is never? That is the question. So is this statement always true, sometimes true, or never true? That is what we need to understand, and that's the very basic question which you need to answer. Well, we know something, that if we divide a polynomial by another polynomial, it is not a polynomial, and that is the reason why we have these rational functions, and we call these kinds of functions as rational functions. So we are saying this is not a polynomial, but it is a rational function. Okay, the reason is that in a polynomial there is no discontinuity. It is always a continuous graph, but when you divide, then the denominator can be 0. So there are some values which are not permitted. So those not permitted values make it something else but not a polynomial. So here we have a restriction that qx should not be equal to 0, right? Since we cannot divide by 0. So we can always divide a polynomial by another polynomial, but definitely with some restrictions, and that is that the denominator cannot have zeros. Now that becomes the definition of a rational function. So rational functions are quotient of two polynomials where the denominator is not 0. So we call this as restrictions on our rational function, or we sometimes say find the values which are not permitted for the rational function. Now let's get back to our first question, that is, when we divide a polynomial by another polynomial, then we do not get a polynomial, or we get a polynomial. The answer is always true is absolutely wrong, but now we have a choice between sometimes true or never true. Okay, so what is your answer? If I divide a polynomial by another polynomial, will sometimes I get a polynomial or never? That is the question, right? Now we'd like to answer this question. So I'm taking up a solution from my student, and then we'll further discuss this in this video. Now this is very important, and I've seen many students making this mistake. So let me start with a very simple example, and the example is, let us say we take a function f of x equals to, let's say 2x squared minus 6x divided by 2x. Now what a student does is, which you will do is, you can factor 2x from the numerators, which is 2x, and you're left with x minus 3, and then you divide it by 2x. Now this can be simplified, and we say, well, 2x and 2x in the numerator and denominator can be cancelled, and what we get is x minus 3. Now x minus 3 is a polynomial, and therefore the student answers that this statement is sometimes true. Sometimes true, and that is the example which gives that it is sometimes true. Now what do you think? Is he right or wrong? Well, as expected, the teacher's crosses and the answer says never true. Now, can you explain me why? The explanation is, and that's a very important explanation, that whenever you cancel, you have to write that x is not equal to 0. Otherwise, x minus 3 is not really equivalent to the rational function we started with. 2x squared minus 6x divided by 2x is not really equal to x minus 3. But it is equal to x minus 3 if I write x is not equal to 0. Now it is equal. But in a polynomial, we do not have any restrictions. So this is not a polynomial. Do you understand? Since it has a restriction. And therefore, whenever you divide a polynomial by another polynomial, it is never a polynomial, right? So it is never a polynomial. It is always a rational function, right? Never true, right? Never true. That is polynomial divided by polynomial is not a polynomial. I hope you get it, right? Now, let me also sketch the graph and show you how it will look like. And we'll explore these kinds of examples in the coming videos. But this is a very basic one for you to understand, and I think is very important for you to understand. So we get here statement x minus 3, right? So f of x is x minus 3, and the restriction is that x cannot be equal to 0. So x minus 3 represents a line with y-intercept at 3. So let us say this is 3 for us, right? So we have a line like this going. That is the line which is x minus 3. But the function really is the line with the restriction x is not equal to 0. So when x is 0, we should have a hole here. Do you understand? So the function is actually represented by this red line with a hole at x equals to 0. Do you understand? So this is my function f of x. A rational function. Do you get the point? So here, this restriction leads to a hole. It is a discontinuous line. It is not a representative of a polynomial. And so we understand that quotient of polynomials is a rational function and it is never a polynomial. I hope that makes it absolutely clear. Thank you and all the best.